Okay, today we're going to focus on multiplying binomials. There are a few different methods that we're going to look at today. I'm going to go over two of them that are the most common that we're going to see. So multiplying binomials, it is using the distributive property, but in a slightly different way here. Our first example, in parentheses, x plus 7 times x plus 4. The first method I'm going to use is called the box method. This is the method I use when I'm teaching it. Okay, so we draw a box to start, and this is kind of using an old school multiplication table where the rows and the columns meet. That's the product of what's at the sides of the box here. So we'd put our first binomial at the top. It doesn't matter the order as long as each row or column gets a term. So x plus 4, like that. Where the two rows and columns meet, so if you look at this x and this x, where they meet we're going to multiply. So x times x, same base, you're going to add their exponents, so we get x squared. A lot of people add there, and that's a common misconception there. X times 7 is positive 7x. X times 4 is positive 4x. And then 7 times 4 is positive 28. I always like to include the signs inside the boxes to make it easier. After we fill in all of our boxes, we write out all of our terms, x squared plus 7x plus 4x plus 28. And our last step is to look for any like terms that we may have. In this case, the two middle terms, 7x and positive 4x, are like terms, giving us x squared plus 11x plus 28 as our final answer. The other way that we can do the same problem, and it's all personal preference, is called a double distribution. Just like we had, if we had just x times x plus 4, we would distribute the x to both terms inside the parentheses. We're going to do the same concept with these two binomials. However, x is going to get multiplied to, x is going to get multiplied to the first term and the second term, but the 7 also has to get multiplied to both terms here. So x times x gives us x squared, x times 4 gives us plus 4x, 7 times x gives us plus 7x, and 7 times 4 gives us 28. The same terms that we had using the box method, obviously. And now here I'm going to combine my like terms, which are my middle terms again, x squared plus 11x plus 28. Okay, the same answer in both examples. Our second example, I see this mistake on all levels of math. When we have x minus 8, the whole thing squared, the common misconception here is they think, okay, I'm going to square the x and I'm going to square the 8, giving me x squared, whether it be plus or minus 64. Okay, that is not the case here. People forget that x minus 8 squared is x minus 8 times x minus 8. If you write it out like that, that should help with the confusion, and we can use the box method again here. Again, be careful with your signs. X minus 8, x minus 8. If you notice, I put my minus sign, or even if it's plus or minus, I put it in front of that term there. A lot of people will put it in the middle, and then they'll make the mistake of not multiplying negative 8. X times x is x squared. Negative 8 times x is negative 8x. Negative 8 times x is negative 8x. And negative 8 times negative 8 is positive 64. When I write out all my terms, x squared minus 8x plus 64, and I need to combine my like terms. Negative 8 and negative 8 is minus 16x plus 64. Remember, when I combine like terms, I'm either adding or subtracting whenever they have the same base and same exponent. A lot of people make a silly mistake of multiplying there, giving me my final answer as x squared minus 16x plus 64. Just to go over this again. This method here that we did in our first example, some teachers may call it foiling. It's an acronym standing for first, outers, inners, and last, which is the order in which I multiplied. First, x times x, outers, the outside terms, the inside terms, and then the last terms. We don't usually see this acronym anymore, but if you were to hear it, that's what we're talking about for this as well. So hopefully that helped you guys out, and thanks.